Right. So thanks for joining it. As I was saying there, welcome to the NEBOSH Oil and Gas. Of course, accredited by NEBOSH. And really on the last leg, right, we do have what is called a special license to keep running the course just for this year and maybe just for this batch, right? We have had two batches already. So I think we have mentioned that to you all, those of us who have this certificate, it's a prize, sort of certificate anyway. The objective of this afternoon sessions, 1.3, outline the risk management technique used in the oil and gas industry. And like you, I am sure you all are tired. And like you, I said, I am also tired. I've had a long work day getting into the traffic, just trying to get something to eat and then to class, right? So you all help me out to this one.
Yes,
Feel free to take part, feel free to just to sort of contribute to this session, and it doesn't just become like an hour of just lecture alone. Anyone is trying to say something, I
you
guess?
hearing me? Yes. So you hearing me?
Yeah. Yes, I am. Yeah.
Okay. No, I know you said it's a prize position, so I was just wondering, on the scale with NEBOSH, what level this it is?
I think it's level 4, but it all depends on the ranking that because in Scotland it's like a higher ranking, but we follow the English system. This is like a level 4 certificate, right? I know like it's 5 in some, like Scotland and stuff, but I think if we follow like NEBOSH level 3 certificate, because we follow that, and then we follow like a master's and a BSc program is level 6. So this would be classed as a level 4 certificate. Yeah. Right. So outline the risk management technique using the oil. I actually do have the syllabus right here, but I wouldn't share it as yet. Maybe if you have some, you could probably run through the syllabus a bit. This 1.3, this 1.4 is taken from the syllabus. But as I mentioned before the recording, we probably wouldn't get into 1.4 today. That will probably be back on Sunday. Right? All right. So you can see the PowerPoint in the background, right? Yeah, everybody can see it. Yeah, okay, good. Right. So risk management techniques used in the oil and gas industry. So the main objective of risk assessments is to determine the measures required by the organization to comply with relevant health and safety legislation and thereby reduce the level of occupational injuries and ill health. Its purpose is to help the employer or self-employed persons to determine the measures required to comply with relevant laws. And in the UK, the law for risk assessment is the Management of Health and Safety at Work Regulations, 1999, Regulations 3. Um, let's just read on. I don't think that's a question, right? Risk management techniques used in the oil and gas industry. So again, the purpose to determine the measures required by the organization to comply with relevant health and safety legislation. What's the purpose of a risk assessment and to ensure the risk is acceptable, to fulfill a moral duty of care to employees, the prevention of workplace accidents, reduce the direct and indirect costs associated with an accident. A risk assessment is the process to evaluate the risk arising from a hazard or hazards, identifying preventative and protective measures, taking account of what you're doing already, right? The adequacy of the existing controls, and deciding whether or not the risk is acceptable. Risk assessment is an analytical process that identifies hazards, who might be harmed, and in what way they may be harmed. So in the UK, the Health and Safety Executive, some of us would know them as the HSE, has a publication known as INDG 163. Um, if you didn't do the search, I could probably back up there a bit, but the HSE has a website. Anybody here can access it. The HSE website is, you can just go to Google and put HSE Home, HOME, and there are lots of free information for the world to follow, and they will have followed it because Trinidad follows the same steps to like a risk assessment then, right? And so INDG, if you want to know, it stands for Industrial Guidances. You can take it on if you didn't know it, industrial guidance. And what a guidance is a book. It's actually free to download from the HSC website, right? So different books that have different series or serial numbers, and INDG 163 is a booklet. It's really a book. It's not even a booklet. I mean, it's kind of thick, right? I have two copies of it. Well, they probably kind of old now, right? But I have two copies of them. right? So it's a good sized book. It's not really it's not like a pamphlet or nothing like that, right? So the name of that book, INDG, Five Steps to Risk Assessment, state that a risk assessment is a careful examination of what in your work could cause harm to people, so that you can weigh up whether you have taken enough precautions or you should do more to prevent harm. So in the book, they have what is called the five steps to risk assessment. I would recommend if, well, let me see. I think everybody here, even those who may have passed the diploma exam, because I have quite a lot of diploma people here, don't I? I have like three degree students who finished the degree in this class, right? I have Nigel, I have Alicia, I have Devon. If I missed anyone, just bear with me a bit, right? And the rest of you all are the certificate students. We also have new students like Akash, and we have Naveen, we have Shinil. These are new students to the institute, right? We have Raven, Bucket as well, Alicia, Kayan, right? So everybody that, right, it doesn't matter if you did certificate, degree, whatever, you have to learn these steps, right, by heart. So remember, this is a memory-based exam, right? So try to commit them to memory, even Stephen, if anybody. I have Alim as well, which is also one of those students who, based on his work, had postponed the exam, right? But try to learn these steps because it's not open book, right? And so identify the hazard, decide who might be harmed and how, evaluate the risk, decide on precautions, record your findings, implement them, review your assessment, and update if necessary. So I would just summarize it, but you all make sure you memorize it, right? So identify the hazard, decide who could be harmed and how, evaluate the risk, decide on your precautions or controls, record and review. You all should be able to say it like that. Now, remember the grand catch with all of these things is that is 11 questions. So um, there is really like, I mean, this is worth remembering because it could come, but these things are never 100% foolproof then, right? And that's why like learning as you go then is kind of important for this course as well, right? So for the oil and gas industry, where the risk is more complex, techniques are likely to require more depth and technical insight. The UK Offshore Safety Case Regulation 2005 require, amongst other matters, a demonstration that all hazards with the potential to cause a major accident have been identified, all major accident risks have been evaluated, measures have been or will be taken to control the major accident risk to ensure compliance with the relevant statutory provision, right? I think what I could do here, I think I could speed it up a bit by just explaining this, right? And you could look at the slide. So for those of us who have an idea, there are about three main techniques to doing a risk assessment. We have what is called a qualitative technique, and this technique uses words. If you want, you could kind of paraphrase that if I guess if we're making side notes, right? So qualitative technique uses words like high, medium, and low, but they do have some advanced techniques that also use words, right? And you'll see some in a bit. At least we'll probably do one today. So keep it in mind, qualitative uses words, high, medium, low. Semi-quantitative uses a formula, and some of us know the formula, likelihood by severity. Frequency is another word for likelihood. Some at the degree level, we would have said likelihood by consequences, right? And so that is like a mathematical formula. You see it on the slide just now, right? Likelihood by consequences. You take numbers sometimes out of 1 to 3, and then sometimes 1 to 5. Let me just put it on the side here for you all. It's actually on the slider, so sort of kind of I really should not have stopped to write it, right? Because it's on the side. So likelihood by severity, I guess we could work with. And what they do, they multiply how likely something is going to happen out of a scale of 1 to 5. And then you come up with that number that's supposed to be a 5. And then you also check the severity as well, or the consequences out of 1 to 5, right? Well, one may mean in terms of severity, one may mean that somebody may fall, but this is really oil and gas. So it's not really that kind of example. We have to look at like a more serious example, like somebody probably getting into a vessel or a tank, right? An oil tank or whatever have you, for cleaning or for welding or whatever, corrosion testing. right? So the likelihood may be higher, the severity may be higher. And then what they do, they multiply these numbers together. And then you sort of rank them out of a scale of 25, right? Anybody could tell us where the 25 came from? A 4 by 4 is 16, but where is the 25 coming from? As I mentioned, we have quite a lot of certificate and degree students here, so you all shouldn't stick with that.
The highest level of risk,
Right,
5 by 5.
right. Very good. The highest here is 5, the highest here is 5. So it's like a number line where you, well, whatever you calculate, you rate it out of 1 to 25. So 16 may be somewhere there. And why this is a semi-quantitative technique for is because when you get this, like when you get a number, you still have to say it as a word. Like when you get 16, you have to say, okay, well, the risk is high. So this technique is said to be semi-quantitative because it uses a number like 16 or 25, but then you're still saying high risk, right? Not very high because I mean 25 or 25 would have been very high. Tell me if you understand this. Some level three, I've seen some questions that actually say 1 to 3. So there is a 1 to 3 matrix, but globally, they extend the matrix to 5, right? When I say extended, literally that's what they did, right? The matrix used to go up to 3 long ago, 15, 20 years ago, it used to go to 3, and then they extended it to actually go up to 5. And nothing is wrong. I've seen questions with 1 to 3. I've seen it at the certificate level. Some of you all may have done questions with multiplying numbers 1 to 3. So instead of 1 to 5, 1 to 3, 1 to 3. So the highest would be 9 instead of 25. And NEBOSH is free to do whatever they want to do. But that is how the questions can vary then, like a 1 to 3 matrix or a 1 to 5 matrix. Many of us know the 1 to 5 because you all have done, well, three of you here, a lot of the certificate students have known the 1 to 5, and even in the companies, they use the 1 to 5 matrix, right? So bear it in your mind, qualitative uses words, semi-quantitative uses numbers, but then the number have a meaning. So it's still numbers and words. So this one is said to be semi-quantitative. Let me get to the next one.
Like it have a way you could tell like what is a high number, a low number. Like if it's from 1 to 5, it's low. If it's from 5 to 10, it's high.
Yeah,
Like
it have
that's
a
how it will
range.
go
Yeah,
until it
yeah.
reaches
It actually
25.
have something called a risk matrix. Yeah, yeah. It actually have a range. Yeah, it have a range, right? So it have a risk matrix, but I guess on a number line, the closer you get to 25, it's going to be like high in the middle, like maybe like around 16. It depends on the range because different authors then have different ranges, just to say it like that, for those who know the range. But the lower numbers is low risk, the middle numbers is medium, the higher numbers is high risk. Why is it different authors? Like everybody have a range now. Like IOSH have a range. Those of us who did the IOSH course, NEBOSH have a range. Then the level 3 range is different to the level 6 range. But they all kind of agree. They may just vary with the middle. Like some people start counting high risk from 20, some people from 16, some people from 15. You could probably download a matrix range. But to me, whatever number they give you, if it's 1 to 3 or 1 to 5, the closer you come to the limit number, if it's 9 or 25, that's going to be high. The lower numbers is going to be low risk, and the middle numbers is going to be medium risk, right? So bear that in mind, the matrix have different authors, right? If you want to do it, bear it in mind, write it down. You can download the IOSH matrix. It's a bit different from the NEBOSH matrices. It's a bit different. Even the ones that come on different levels, like the level 2 matrix is different to the level 3 matrix, etc. Right? But I think they all agree with hold on a bit, right? Yeah, so we all agree with the getting closer to the upper limit then and getting it closer to the lower limit, right? And there is no really wrong, like these multiplications, like you wouldn't really get a mark for the I mean, you get a mark for the calculation, but there's always a range then, right? So once you end up in the range, if they say calculate the risk of somebody getting into a vessel, and it has been purged with nitrogen, or maybe it had hydrogen sulfide. I mean, you're already thinking high risk. You just said to prove it. So the person that gets 20, the person that sees it as 20, and the person that sees it at 25 gets the same mark, because those techniques tend to be a bit subjective, right? And so NEBOSH knows that. They know that there is a range. If you look somewhere here, you may see that those techniques are kind of subjective, even the one with the numbers, right? So for exam, don't think then that, okay, like they are looking for 20 or the 20, or well, 20 or the 25. They're not. They're really looking for the range. And once you end up in the range, you'll get it correct. Tell me if you're okay with that. Please take a note of it. Don't just listen to it. Write it down so that you're clear on it anyway. Right? Everybody okay with that? Yes, no, yes, no. Give me a thumbs up. Say something. You can hear me still? Yeah. Okay, good. Right. Well, moving to the
Yeah,
next one.
okay.
Okay. So the next one is the quantitative technique. Now, some of us at the degree level may have seen this one already. That's if you did, well, I know some of you all finished the degree, right? So there's a quantitative technique. And the long story short, the quantitative technique uses actual numbers down to a decimal point. That's the simplest way to say it. So it's very objective, and like there's a whole set of numbers then, right? Like like the risk matrix would never get 15. If you follow the scale, you'll never get 15. Well, you probably could get 15, I guess. 15. Like some numbers you wouldn't get. The point is, even if you get 15, 16, there's a whole range of numbers between 15 and 16, or between 16 and 20, right? And even there's a whole set of numbers between, like when I mean numbers, like, I mean, like other than the actual whole numbers, right? Like 17, 18, like you never get 17 on the matrix, would you? Because that's a sort of odd number, right? But there's a whole set of numbers then, like even around 17, like decimal points. So the truly quantitative technique uses, like down to a decimal point, right? So 0.8, 0.9, 0.99, right? So a truly quantitative technique, 0.999998, that sort of thing now, right? So that sort of calculation, all of us from the laboratory here, you'd have never seen that before, but just to let you know that that technique does exist, and it actually have one here as well, right? So let's get to the next slide. We'll see if we can come up to that anyway, still, right? So tell me if you understand them. Qualitative uses words, quantitative uses like a mathematical formula, but still words. However, quantitative uses like pure maths. Like when I say pure maths, those of us who understand that, they use what is called binary, like the whole set of numbers between zeros and ones. There's a whole universe of numbers between zeros and ones, right? All of the decimal numbers and stuff. So it's a bit more, you know, accurate. If you look at what they say here, it's meant like for calculation for evaporative rates, thermal radiation output from fires, but check it, gas release and dispersion. Now, that is kind of like what oil and gas is all about, isn't it? Like calculating the probability of a failure of a valve, calculating the dispersion of, I guess, flame, fire. So most of these things are done by computers, but the point is they do have this type of calculation. And we do have one here as well. So we'll get to it when we get to it, right? I know it's not the next slide as well anyway. Let me take off what I have in the middle here to get to the next one. So these go. You see, I tell you today was an important class, and that's why I kind of said I figure we should have kind of get on with it anyway, right? Qualitative techniques or advanced techniques, we have hazards, hazard identification techniques, HAZOPs, hazard and operability studies, bow tie analysis, failure mode effect analysis, what if analysis. So kind of try to look at this a bit, just look at this a bit and see if you understand that these techniques are kind of advanced. Well, they're advanced. None of them, I mean, unless you did like a level 4 course or a level 6 course, right? None of these are taught at the other levels then, right? So these are advanced techniques, but if you look at them, they are classed under the heading of qualitative, meaning that these techniques actually use words, right? Strange, right? So they use words, they advance, but they still use descriptive words then. You'll see, I could probably do two. I'll probably do the two most famous ones. I'm looking at them and I know the two most famous ones for exam anyway, right? Um, so quantitative techniques, these are some advanced words as well. Fault tree analysis, depending on the availability of supporting failure data. Hazard analysis, event tree analysis. The benefit of using a quantitative technique is that, as we said before, it uses maths, it is objective. It's reliant on failure and reliability. Data is very precise and reliable. Well, maybe a quick story, right? So the last line says it's reliant on failure data. And so the best story we could think about there is like maybe God forbid, God forbid, right? Like an airplane crash. You all know what they try to retrieve. What do they try to retrieve? God forbid, an airplane crash.
Black box.
Black box, right? And so that have the data in it then, right? That they could pinpoint, like what time did the flight go down, when did this engine, God forbid, went out. And so the same for ETA calculations. So I was saying this, right? And in my mind, I have not seen an ETA calculation for oil and gas, right? But we see advanced techniques, but most of them kind of come on this side. But it's the notes and it's the course and it's the syllabus, so we have to mention it anyway. So, like, in the world of safety, then, like when they say failure data, like if there was a fire, again, God forbid, they would look at the components then, like that was in the room. So if there was a smoke detector, if there was a fire alarm, they would look at it like the manufacturer's data on it, and they could try to extract from those things then, like maybe what went wrong, right? And so with um an actual question, though, NEBOSH will provide you with the failure data. They will say the smoke detector stopped working at 0.86 seconds. Remember, this is quantitative, right? They would say the control panel, right, failed to alarm in a gas a process environment, right, at 0.9 seconds or something, right? So you don't have to really worry about where the data is coming from for an exam. But I just saying like in real life now, like they could actually pinpoint the data from instruments and not just smoke detectors, but think about the other things I mentioned, not just airplanes and stuff, but a lot of digital components and stuff. They could get the data and they could pinpoint maybe what went wrong with the manufacturer's specification, and they can get that and they use that in a calculation, which I would probably get to on Sunday because we're gonna go into two of these here now anyway. Yes, Devon?
Oh, no. So I was just going to say on the CBS site, they also had a lot of videos where the piping wasn't rated for the gas, and because of the pressure, it caused it to rupture, and that led to basically a disaster. So
You remember what case study that was? What business it was? What anyway, those of us who are not familiar, the CSB, the Chemical Safety Board. If you're in safety here today, you should be familiar with a couple of websites. One of them is HSC. The other one is the CSB website. Please, I know Devon put the videos there for you, but you all don't be too lazy. Just try to get the site yourself, especially if you're in safety. The Chemical Safety Board, CSB, they have really nice videos, folks, right? They have videos with, it's never boring. A CSB video is short. If you want to share a video with your workers, a CSB video is short, it have reality in it, and then it have animation in it. So like one of the things they are good at is like crisscrossing reality and animation then, right? So you'll be looking at a real fire, and then they go into the schematics of the room. right? CSB videos are excellent. I'll say it one more time. If you're in safety here today, you should be familiar with two websites, the HSC site and the CSB website. The HSC site doesn't have any videos, but lots of books and documents. CSB sites, great videos, short enough. 5 minutes, 6 minutes, 7 minutes. It wouldn't really take up much of your time, but powerful videos. They analyze accidents from around the world and they sort of try to figure out what has gone wrong. But the schematics is very good. Like you'll be seeing a real tank on fire, and then it goes into the schematics of a tank, right? Excellent stuff. Can never go wrong with a CSB reference anyway, right? Let's see if we could probably well, this chart summarizes the 5 steps. Who can be harmed, right? So what's the hazard? Get here. What's the hazard? Who can be harmed and how? So this is like the how here. Then we multiply the likelihood by the consequences, that is evaluating the risk. You come up with an assessment, and then you probably say, like, do you accept that, right? So, like, do you accept the risk level? Like, it could actually be low, it could actually be 1/3, in which case you accept it, or you say, but the risk is kind of high, 16 or whatever have you. So then you're not going to accept it. 20, definitely 25. You're not going to accept that. This is not to learn. This is a summary. So this is not to learn that, right? The formula is there. So I already wrote the formula here, likelihood by severity. Some people say likelihood and consequences. Some people say frequency and severity. The word is just a word. The idea with them is the same thing anyway, right? So this one here, I think we could spend some minutes on this one here, right? This is called the reasons model. But reason was the man's surname, right? Reason. It has gotten the nickname the Swiss cheese model based on the slices of cheese they have like in Europe and stuff, which is kind of common. And what they basically say here is that for an accident to happen, all the negative events had to happen in a certain order. Then it's kind of like Final Destination, like that movie Final Destination. Most of the times, you know, uh, most of the times an accident happened, you could actually look back and you could trace back. This is actually so true. You could actually look back and say, well, you know, the CEO didn't come today. That's why the supervisor took over. But the young worker didn't know what he was doing. At the same time, the supervisor attention was somewhere else, and the young worker got into the forklift. He had basic training, right? This in that same day, in that same time, John, the senior operator, wasn't there. So when you look back at it, because I've had it happen, and I'm sure those of us in safety have had it happen too. You look back at it and you realize, yes, yeah, all the things that actually line up for this accident to happen, right? Anyway, the point of it is not only that, the point of it is that the model itself, right? The model itself takes into account, I don't know if you want to see it here. The model itself takes into account like different types of failures that if you trace it to the end here, what you're gonna get is like management failures to the end of it, right? So some people refer to this as hidden failures then, right? Like you would see it's kind of like the known and the unknown. It's like the seen and the unseen then, right? So like what you may see an employee not wearing eye protection. But the point is, so then that's like a seen failure, right? You can actually see that. Working condition that is actually seen as well. Poor fitted eye protection. I could probably add to it because you see there are more circles here. So you can say at the same time the chemical that was being handled was, God forbid, a corrosive chemical, right? We could put a lot of things in order then to see maybe like the proper vessel may not have been used. But when you trace it back, then you're gonna see like it goes back to management, right? So management system failures, no safety training, no written procedures. And this is just a basic look at one of them in terms of the Swiss cheese model. So for the eye injury to occur, the worker, had to not be wearing his eye protection. Like we can ask why it was poorly fitted. Why was it poorly fitted? Probably they didn't do a fit test. Maybe they chose the cheapest type of like safety glasses, right? And why did they choose the cheapest one? Maybe it was because the focus was on production. So there are more management failures than other than no training. It's like the focus was on production. Maybe you were waiting on a budget funds to purchase some good, Z87 glasses. Or in this case, well, goggles then are not really glasses. If it's chemicals they were looking at, it probably would have been goggles. Maybe you were waiting on a budget to sort of purchase a face shield, and then that budget never came true. So you use what you had. And all of that all of that lined up in that day, in that hour, at that time for the accident to happen.
Type Alpha and Texas City would have fall directly into this category here.
Yeah, yeah. All right. Yeah. All right, let's so I trying to see what you can remember because like I've seen Swiss cheese model questions, but they draw it for you, right? Again, NEBOSH is free to do whatever they want, right? Let me see what we have here. If measures are put in place, management system, information, instruction, training, well, then the accident will be prevented. Well, that's a good thing with the Swiss cheese model, right? Once you turn one of the circles then, or once you put a control measure into one of the places, which is what probably normally happens in our everyday life, like one person, sorry, I'm trying to get the marker running away, right? So like one thing that could have been, so yes, it could have had no training, but if the worker just had the proper glasses, then the accident would not have happened. So like you turn this circle then, right? So they could ask you like what is four controls. Remember, you all get 8 marks a question. So a nice question. I'm not saying it is, I'm just thinking out aloud. A nice question is like four causes of an accident. You could link it back to the Swiss cheese model. And then four controls will be linked back to those four causative agents. And if you say no training, but then the control is just proper training, proper supervision, right? So again, I don't think your questions are that hard. I'm trying to see if I can get one done tonight as well, right? So moving along, the concept of hazard realization. So once any of the barriers fail, well, two or more barriers fail simultaneously, you'll have an accident. You can read this up. That's all that this says, right? When two or more of the controlling barriers fail simultaneously, the harm is now evident. I think maybe if one fail, you could still have a control there anyway. But if two or more fail, it's kind of like dominoes anyway, right? But a little bit different to dominoes because I think in dominoes all have to fall, but in this case here, one or two could fall, and an accident could still be apparent. It mightn't be as worse as if all the barriers fail, but the Swiss cheese model does kind of say, let's not get confused with it, right? The Swiss cheese model does say that all of them have to fail at the same time. There are different models, and if you hear me say domino, that's like another model, but the Swiss cheese model does say all of them have to fail simultaneously, right? In a sequence events, kind of like the Final Destination movie. And if that happens, well, then you would have an accident. Can I take off? I've taken off all the drawings there. I don't think we need this on this side anymore. All right, let's see if I can get
Um,
another one done. Yeah, go ahead.
the PowerPoint that you sent for us yesterday
Yeah.
is limited to what I'm seeing you showing us right now on the screen. I have I have a printout here right now. It's up to
Yeah.
just 40 slides.
Okay, and what
Yeah,
side?
the one I'm seeing you have there is 70.
Yeah, not a problem. I'll send you this one, right? I know sometimes I am
Sorry?
I'm actually, but you all have, so you all could see this, right? Yeah.
Yeah, I'm seeing what you have, but
Yeah,
the one
not a
that you
problem. Yeah,
sent to
yeah.
the email is
Yeah, what
just
happened?
20 slides.
Yeah, this time of the year, I go through all my PowerPoints. So I kind of update them as we go, right? So I'll send you this one if you don't have the whole version of it. But I know you have enough for today. I think that one that I sent you, I was working on it. You'll probably see it marked sample. We normally have to update them, get them approved again by NEBOSH, etc. Right? So, but I think you have enough
Yeah, it marks up.
for today. Yeah, yeah, you see marked sample. I know that because I know I was working on that one, right? I'm actually like when I'm not in front here or teaching in front of any company, I'm actually actively working on the slides behind the scene to get them kind of up to standard. And that's a yearly process anyway. It happens every year. This time of the year, February. Well, I would have started January, February, March, etc. Right? All right, risk management tools. Well, we kind of mentioned them before. That's all of the different techniques, right? So these refer to the approaches used to predict and prevent risk from being realized. We have mentioned them already there. We mentioned HAZOPs, we mentioned ETAs, we actually look at Swiss cheese. Let's have a look at well, if you want to see this one. So a lot of the techniques can be used at different stages of a project. So project phases and suitable risk management methods. So at the conception of a project, there are techniques that you could use, and one of those techniques is this one, a HAZOP. You could probably link that one time. Well, it's right on the slide anyway too, but right, if you see here, this point, right? A HAZOP identify deviation from design. So if you have a project, whatever project you have, I mean, whatever you'll do, clean tanks, weld, construct buildings, whatever, right? If you have a project, different techniques could fit in well with certain stages of the project then, right? At the design stage, like right here, you see a HAZOP could actually be used. The ETA is actually not used at the design stage, and ETA is actually used after an accident, like God forbid the airplane crash, where we have to retrieve data from the black box. That's not designed. That's after an accident, right? So just at the different stages, I just did one, right? So concept design, project planning. Maybe a good one for that is a bow tie analysis, project planning. I'm just saying, we probably wouldn't do all of that today, right? Detail engineering, maybe a ETA if we have all of the data, but we wouldn't have all of the data, right? Construction, turnover and startup, commissioning, operation and review, modification. A HAZOP could be used for modifications as well. Decommissioning may be an ETA again. So just before we leave this slide, there's something on this that I want to tell you. I saw a question on this, right? I saw a question on this to name, it could have been four stages, phases of a project. So when you look, like like a slide gains importance then because of past papers, right? And so other than that, like we could just have questions in it so we kind of slow down there. So this too, you could probably try to commit this to memory. Maybe on Sunday, I could ask you. You could look at the easy ones, right? Concept design, project. I mean, you don't have to learn it in order. If they ask four, then you could give any four. Construction, modification, decommissioning. That's not hard. Turnover, right? None of them had, but yeah, they commit them to memory. Keep it to the back of your mind, please, that this just to identify four phases of a project was a passive question. Yes, did you all write it down? You don't want to come out of the exam and say, you know, I remember still talking about that, but I didn't study it. It's too easy not to commit to memory. Modification, design, commissioning, decommissioning. Look, four already, right? That's four right there. But please commit it to memory because the focus here was a passive question. All right, HAZOPs. I'm gonna read and then I'll explain. So first used by the Imperial Chemical Industrial Company in the 1960s, ICI. HAZOP stands for Hazard and Operability Study. It is a structured and systematic examination of a plan or existing process or operation in order to identify and evaluate problems that may represent risk to personnel or equipment or prevent efficient operation. I'll explain at the end, right? It will identify deviation from design intent, so very good at the project planning stage, determine the causes and recommend solutions. Yes, it does that. It is a qualitative process that can be used in the conceptual stages where we sort of mentioned that many times. It could be a concept selection. Not too sure if they would link it, but there is a link. I'm not NEBOSH, I'm just telling you, right? I'm not too sure. The question was, the question didn't link it, but yeah, you could link it. You could link the different stages of a project to different risk management techniques. So with a HAZOP, a team of experts and various disciplines are involved. However, a team leader is usually chosen. It is best used at the design stage in a process, but can be used for plan modification. team members could include, well, most people who are part of that project, right? Secretary or a scribe. You see why you need them, and a bit design engineer, mechanical engineer, electrical instrument engineer, operation representative, process engineer, safety specialist, supervisor. The list goes on anyway. I don't think it's kind of limited. We just put the main ones here. So with a HAZOP, a scope must be defined, such as the part of the process that you're looking at. A parameter must, remember you want to do a HAZOP, it's like a phase then. If you go back to this one, it's like a phase, right? Concept. Like if, I mean, even if you were building something, say you all know I'm building my building now. I made that known to my NEBOSH diploma class. So like, like we passed the excavation stage, we're on the foundation stage right now, right? So like it wouldn't be everything in one then, right? A HAZOP doesn't cover everything in one. A HAZOP is like you're looking at excavation and then like what could go wrong with that, right? You're looking at foundation and like what happens there then. So if it was a building and if it was, I guess, a tank that you were cleaning, there are different parts of that tank then before you get to cleaning. You may have to isolate. And then like what's the hazard with isolation? You may have to drain and pump out the oil and the water and the sludge. The sludge is a different story because that is a contractor, right? And then finally maybe to kind of wash the tank, power wash down the tank, then to probably get workers inside there to weld and then test the welding. So there's lots of pieces to it then, right? So a parameter must be chosen, right? As you point about that, right? So with this one here, typical parameters, if we come away from the tank example, could be flow, pressure, temperature, level, whatever you are looking at, like the level of fluid in a tank, that's called the parameter, right? I have one here, for example, temperature of sulfuric acid in a pipe is more than 20 degrees. Guide words must be chosen. I'll explain that in a bit, but guide words include words like no, more, less, as well as part of, reverse, other than. You could just commit two to your memory. They actually have more guide words than that, right? I'll tell you what guide words are in a bit, right? And so what the guide words mean, no means a negation of design intent. For example, the temperature was supposed to be 20, but it's not even getting hot, right? Or the tank's supposed to be filling with oil. You turn on all the valve in your location, which is like a tank location, you turn on your valves, but the oil not coming in. So somewhere down the line must have a manifold, and somewhere in that manifold, a line must have been off. Or maybe the line is broken, right? And like in the oil and gas industry, then maybe the line is broken and the oil is spilling somewhere, right? And so that's why you have the valves open. So no means it's not the like not happening, then what should happen is not happening, right? More means a quantitative increase, less means a quantitative decrease. Reverse, the opposite thing is happening, as well as a qualitative increase, part of a qualitative decrease, other than complete substitution. The most common famous words for exam is more, less, and no. So you could just stick to that, right? Now, what I should tell you is that these words could change meaning. Well, other than no, more, and less, right? The words could change meaning. Who would change it? The team, right? So I'll explain that a little bit for you. So a HAZOP have a heading. Remember, HAZOP is a risk assessment, right? If you look at the heading here, it's a risk management tool. So HAZOPs have a heading. I think my degree students may remember. The heading is GDPCA. And those are the headings on the risk assessment. So if you want to kind of write that down, we could work through one of them, right? So process plan scope, the cooling of sulfuric acid in a storage tank at 20 degrees Celsius. The parameter I choose is temperature. The guide word is more, an increase in temperature. Well, we could go with, we have to pick one because if you're doing a row, you just pick one word then, right? Possible failure could be valve failure, trip sensor, valve close. Consequences, temperature goes above 20 degrees Celsius, resulted in an increased pressure inside the storage tank and subsequent uncontrolled release of vapor. So we need to back up a bit, right? This is how we can show it in a table. We need to back up a bit. I need to tell you something about the guide words, right? So where these techniques came from is the military, right? And so like, I mean, back in the day, I mean, not back in the day, I mean, we have wars in the world today, don't we? Right? And with certain political leaders in America, who knows what that happened, right? Somebody came to my office on today's what day? Today's Wednesday. I teach every day, right? So it had to be yesterday. I was thinking Saturday, but it couldn't be Saturday, right? And she was telling me something about wars and stuff, right? And I mean, I really don't know the student too much. And I was like, I really haven't had time, folks. If you all know me, like I work like after your class. I have two things. I have two other meetings tonight. Turn off the computer and go to sleep, right? And so I haven't looked. Is that something happening now? Is it that like in the news they're talking about something with Trump or something? Because I really don't know. I honestly don't know, and I honestly don't have time to know, right? So from what she said kind of like yes. I didn't see nothing. I have my screen right now is on like some background music. If you all come to the office or something, see, that's the same way I'm actually at home as well. I really don't look at too much news. If that's the case, you all let me know. I really don't know if any such thing has been said. I know there's some mass deportation of Caribbean people back to the region and stuff, right? I know from England, from being in England, they kind of more favor in their own right now. Their own being British national of Caucasian descent, right? So that's a kind of thing going around the world now. It's not a good place, not a good time to go to America, not a good time to travel to England anyway, right? But I honestly don't know, right? Anyway, so folks, if you want, what I was saying is that so they use codes because of the wars and stuff, and yeah, you'll remember some of the codes, like I mean, everybody knows some codes like Roger, the Eagle has landed, right? Delta, Bravo, those kind of things. So that's where the technique came from. And what they're saying is that you can actually choose your own guide words. But these are the popular ones that no more and less, right? So like you could choose your own guides. So like you could say none instead of no. You could say like how they have other words. Like you could say the team when they meet, they will set the word. They will say, okay, if I say what's another word for more? Much. If I say much, then much means increase. So you could make up your because it's just like that. A HAZOP is free to make up your own guide words. Um, eh, at different levels, they have a whole list of them. It's never exhaustive. You can make up your own guide words, right? So just understand that part of a HAZOP, right? So the GDPCA, what I was telling you all, that represents the heading on the table, right? So if we look at the process, if you all look at the same one I have here, let's look at the same one I have here, right? Like the slide have to turn again, right? Give me a minute. Zoom is a little bit funny. You have to take up the marker to get the slide to go. Yes, if we look at this one, right? If you look at this one, so the parameter, so this is like storing sulfuric acid in a storage tank. This could be this is used in a lot of manufacturing companies, right? For making juices, right? SM Jaleel and stuff. A lot of companies do something like this. They have, like a certain amount of acid, and it doesn't have to be sulfuric acid. I'm just saying it could be, some sort of ascorbic acid that is used in juices and stuff. So I'm looking at a process like that, and the parameter I'm looking at is temperature. If you want, write this down with me a bit. So the parameter is normally stated at the top of the table. Parameter stated at the top of the table. Write it. I guess yours could write better than mine, right? Parameter we're looking at is temperature. And then remember, this is a risk assessment. So normally a risk assessment have a tabular style then, right? So like instead of the first step then should have been hazard, it wouldn't be hazard, it'll have to be guide word. So that's what the G. The G stands for the guide word. Let's put in guide, right? You could write the whole thing. So the heading follows the format of GDPCA. So the first thing, and this would be like a column, but I won't draw the column yet, right? Or maybe I could draw part of it, right? So that'd be a column. So the next thing will be so GD. So the next thing is deviation. So deviation says that the temperature is going up beyond the 20 then, right? So guide words, then you have deviation, that's GD. If you want, you can write it back to the top there, GDPCA. right? GDPCA. So the G is guide word, the D is deviation, the P is possible causes of the deviation, right? So possible causes of the deviation, and that could be maybe a lack of maintenance, right? A lack of supervision, a valve failure, possible causes. What's causing the temperature to go up? Maybe a operator didn't turn off a tank in time. Maybe a thermostat blew, right? Blow out, as they say. So GDP, that's possible causes, GDP. C, if you want, please continue, will be consequences. I think I have it down. Look at here. Consequences, possible causes here, right? But it's on a tabular format now. It's an advanced RA. Of course, it uses words, right? So I'll stop it there. Consequences. And if you look at the heading, if you look at what a HAZOP is, or even all risk assessments are meant to control. Like the purpose in getting 16 out of 25 wasn't really to say 16 out of 25, it was to suggest a control. So GDP, C, possible causes, A is the action plan, right? So A, GDP C, A is the action plan for improvement, action for improvement, right? Now, again, for all our students now, before those of us who did the degree, you may have had the opportunity to use your book then to get this back. But remember, now you have to memorize it. I think most of you all know the HAZOP heading, those of us who did the degree anyway, right? But if not, and maybe for you, the degree, like Nigel may have been last year, right? You may need to remember, try to commit it to memory. Guide word, deviation, possible causes, consequences, action plan. There will be the video, of course, but it have to go in your head because this is not an open book exam, right? So if we look at this, so the guide word we could look at here is more. So the team will say that. The team will say, let's consider the word more, right? And more will mean, we already know more means the temperature increases, right? So the guide word more, an increase in temperature. So it should be 20, but it goes up above 20, right? And we can think of this, let's stick to, I've used the same example for, well, an example everybody could relate to, like manufacturing soft drink, manufacturing juices, SM Jaleel on the island that manufacture, the orchard juices. So above 20, that's the deviation. It should be 20. Look at here, it should be 20, but the deviation is above 20. What's the possible causes? I already did it for you. You could write it down if you want. Valve failure, I'll just put valve here. Valve failure, right? Could be a possible cause. And there could be a host of other causes. If you ever get it for exam and they tell you suggest 4 causes, that's really nice. You can talk about human error, mechanical error, manufacturer's defects. What about even sabotage? I can't say this for 8 marks. I could see it for 4 marks, right? They actually, and sometimes they give it like a 2-line, 3-line, like what's the possible cause? You can see the valve fail, maybe lack of supervision, maybe human error, the operator got distracted, maybe even sabotage, right? So the consequences is never good. I have your uncontrolled release of vapor, right? So you can probably stick to that. Coming out of that could be like a fire because the temperature is increasing. It doesn't have to be in the manufacturing industry. It could just be that the temperature of the juice now has gotten too high. And now, anybody could guess what happened? What do you think they'll have to do with that batch in that tank? Of, if we stick to the juice example or soft drink example, soda, for those of us who may be looking on the internet, what do you think if the temperature has gone up to, like, so the juice got more heated?
Yeah, to get rid of it.
Yeah, they
Yeah,
get
to get
rid of
rid of
it.
it.
You can't sell it. If you sell it, that's the end of your product there, right? So a consequence for the manufacturing industry could be like product wastage. They have to dump it. Of course, selectively dump it, of course, meaning they wouldn't dump it in the river, right? They would dump it into their, units, for disposal, right? So the action plan could have been here proper inspection, right, of the valves, the action plan. The action plan is like the improvement then, right? Proper inspection. The action plan could be things like proper supervision, maybe routine maintenance. And again, you're going for 4, so that's already 3. Hopefully they kind of give you a bit of a head start with it in some sort of scenario. And then folks, that is one line of a HAZOP, right? So A HAZOP is like rows like that. It's a table, right? So if you want to look at another possibility, then that's another row. So if you want to look at less, the temperature decreases, that's another row. I wouldn't do that one. If you want to look at as well as, the manufacturing industry does use as well as for contaminants, like it have a fly in it, right? But folks, remember, this is, don't get lost, right? This is, how to say this? This is a what if analysis. The truth is, this hasn't happened yet. Why this not happen, but like why this haven't happened yet? If you look back, no, I'm not going to scroll back down or scroll back up. Remember, this is used at the design stage. The truth is, we like we saying, what if the temperature has increased? A HAZOP is used at the design stage or phase. The truth is, there is no fire. The truth is, the product didn't waste. But we're saying what if, and then how do we control it then? So the action plan, remember, that's what a risk assessment is. Keep in mind, a HAZOP is just a big risk assessment. It's not really meant to highlight the hazard alone, valve failure and stuff, but it's meant to control it at the design stage. Think you understand that? So it's totally proactive then. It's saying, what if this happens? What if that happens? What if a fly gets in it? What if you go back to a tank example, what if a worker gets inside of the tank, how does he get rescued? What if rescue is not available? How do we get him out of there? Right? So it's highly proactive in that sense, which is why they said it's used at the design stage. Tell me what you think. I want to show you a quick past paper. Tell me if you're okay with it. Um, like I said, the thing with this kind of exam now, I mean, this is how it was before the pandemic, right? Where we kind of had, I mean, there are some famous questions, you know, but like you will get repeat. But the thing is, we don't know what exactly would be repeated, right? Let me see if you're all okay. Example of a HAZOP, Devon put one there. Very good. Thanks, Devon. We do miss you at the degree level. The same thing you did for us there, you are doing for the class. But folks, you all don't be too lazy. You all kind of look up these things for yourself. Go on the CSB website, check up some of these things for yourself, right? So this is a question here. I didn't really, well, we only have time for one. Look down here, right? Outline the concept of as low as is reasonably practical. But I think by Sunday, that's on the same PowerPoint. I'll send you all of the slides, right? That's for Sunday. But that question was repeated, right? So very simple question. Let's just kind of focus on one. 4 properties of hydrogen, 4 hazards of hydrogen, right? So, the thing about having a paper is you could start to plan then, start to plan. I think this was a nice one here, permit to work. December had permit to work as well. All right, I'll just read, right? And I'll stop when I finish reading. So one of the stage of risk assessment is to identify the hazard. What stage is that? Anybody? What stage is that of a risk assessment? Risk assessment, 5 stages, like 5 steps. Anyway, that's step 1, right? Identify the hazards associated with crude unrefined oil during extraction, storage, and processing. So you can take it like that. You can get the hazards under extraction, some hazards like extracting it and then think about it, right? The hazard of storage, think about that a bit, right? Like spills, the hazards of processing. Again, you could probably research it a bit. The top of this, though, I didn't see it come back, but was E I was talking about, right? Part E or letter E that was repeated. Identify 2 types of risk assessment techniques. Anybody could show them? We did them today. Show them quick.
Qualitative and semi.
Right. Quantitative and semi, right? Good, good, good. Of course, like I said, you're not really studying, but you're not studying tonight. But when you're studying now, you know these things in the top of your head, right? Outline a typical 3x3 matrix that can be used to assess the level of risk. So you could just talk about the risk formula. They'll even give you one here, right? The summary of risk evaluation is often drawn in a table similar to the one below. Study the table. And we're just gonna bring this down a bit. So study the table and each of the X and Y and Z, and for each of X, Y, and Z, outline the type of action that should be taken in relation to the corresponding risk level, right? So like this is just control. Like how do you control low risk? Well, low risk you kind of monitor. Medium risk you take action, but it's like action within like maybe a week or 2 weeks. But high risk you have to stop the job to put adequate controls in place, right? So I was telling you all about matrices. They could have a different one here. NEBOSH filter makeup one. This is going to 3, 1 to 3. 3 by 2 and 9. 9 will be the highest, right? Tell me what do you think? I think we had a power pack class. Despite me feeling, and I think everybody would be normally tired at the end of a day, right? But I think we still had a good class anyway, right? So thanks for joining in. Let me I do have, it's 7:30. This is the time we have to stop anyway, right? Let me kind of get your names, and I actually left your register in the office, right? In the melee, I like if today I was thinking about, for those who know me, just staying in the office, right? Do like those of us who know that side of me, I would stay there. But then I'm thinking, Trinidad isn't too safe, right? I am very guilty of staying in the office late, 9 o'clock sometimes. And I said today, is either I had gotten in the car and tried to get to where I was getting to, or stay there and then have the class, and but after the class have 2 meetings, and that'll push me to 9 o'clock leaving the office. Sometimes I do it, sometimes I don't. It still is carnival time, which is not too safe in Trinidad. So in the melee then I put stuff here, I put books and stuff, but I didn't put your rows. So I have to take it down manually. When I go tomorrow, I would enter it into the register that is on my desk, right? Let me just get your names. I think I'm seeing well, I'm missing Alim and some of those students, and Stephen left us because he had to work, right? So oil and gas, today is the 12th of the 2nd. I'll just call it from here, right? We have Akash. Yeah, okay, thanks very
Present,
much. Do enjoy the rest of your night. We have Alicia.
Present.
We have just give me back the Thompson again. Thompson was the first name again?
Rashad, Rashad.
Yes, Rashad Thompson, yeah. Right? Rashad Thompson. Jessica Alfred. Once you say present, you can leave, right? And of course, do enjoy the rest of your night. Jessica
Yeah,
Alfred.
present.
Yeah.
Yeah,
Thanks very
present.
much, Jessica. Good. Alicia. Kayan.
Present,
Definitely.
sir.
Yeah, definitely. I think this video needs to go on YouTube. This is a good class we had today, right? Crystal Thomas.
Present.
Thanks very much, Crystal. Devon Lewis is here. Naveen, right, is here. Yeah. Raven Buket is here. And we have Chenille Ryan is here, right? So I have 10 of you, one of me. So that is everybody, folks. If you're still around, do enjoy the rest of your night. I'll see you all back on Sunday. All the best, everyone. Bye.